All right, all right, all right. So today we're doing problem 3, a 0, an 8, a 4, count substrings starting and ending with the given character. This is the perfect kind of problem that can be very easily solved if you've just done a lot of Leetcode, right? There's some problems where independent of how much Leetcode you've done, they're just hard, right? And there's some problems of independent of how much Leetcode you've done, they're just very simple. But there are certain problems where it really justifies the effort of just brute forcing through a bunch of problems because for whatever reason, brute forcing through a bunch of problems makes problems such as these pretty trivial. Okay, so all that's to say is don't give up. The effort's worth it. And, there's a high probability within an interview that you encounter a problem similar to this. And this similar kind of set of problems will be easy to solve if you have prepared yourself by doing a lot of problems. Okay, so with that said, let's go ahead and get right into it. Okay, so very simple and short description. We love those, right? Basically, you are given a string S and a character C, and you just want to return the total number of substrings of S that start and end with C. So does that mean so you're given a string S? All right, that's pretty common, right? We've seen things like that before. And you're given just a letter, one letter, okay, one letter C, and you want to find the number of substrings that start with that C and end with that C. Okay, so seems pretty intuitive, right? But how do you actually go about doing that? Well, let's just look at an example first, and I think that'll probably reveal exactly what's going on if there's any confusion about what this problem is really asking. All right, so on our example, all right, we have S equaling AB, ADA, AB, ADA, and our character C equaling the letter A. Okay, so all we got to do is find out the number of substrings that start with this letter C, the character corresponding to the variable C, which is A, number of characters starting with A, and the number of characters ending with A. Okay, so we could manually just walk through those, right? So there's this A by itself, so that'd be 1. There's this A by itself, so that'd be 2. Whoa, don't know why I did it like that. There's this A by itself, that'd be 3. There's this A, these two A's together, so ABA, that'd be 4. There's AB, all these A's, that'd be 5, and then there'd be AA, and that'd be 6. And that's why there's 6. 1, 2, 3, 4, 5, 6. And those strings together, if you want to write them out, right? There's A, there's A, there's A, there's ABA, there's ADA, and there's ABADA. So that's 1, 2, 3, 4, 5, 6. Okay. Now with this ZZZ, you can see it gets really complicated, right? Because you have ZZZ by itself, you have ZZ, ZZ, and ZZZ. So 1, 2, 3, 4, 5, 6. So 1 for all the Z's, so that'd be 1, 2, 3, 4, 5, 6. All right. So this problem's pretty simple in terms of its description, right? There's nothing like got you. There's not like, 10 bullet point conditions about what can and what can't be done. So how do we solve this? All right. So there's really only one observation you need to make to solve this problem, right? And that is, well, for each, in order for this to be valid, what has to be true? Well, there's just 2 conditions, right? Has to end with a C, C being the variable, and start with a C. Okay? Now, the reason why I'm saying that is, let's just imagine that we had, I'm putting X's here to represent that it's just something. Okay? And then we had a character C. How many, saying that we don't know what these X's are, right? And all we know is we have the character C here. How many substrings can we create with this character C? Well, we can create one with the C by itself, right? So that's 1 in our solution. I don't know. Let me zoom out of here a little bit. I'm kind of zooming in too much. Okay, so that's 1 in our solution. And then how many more could I create with this C? Well, that's dependent on the number of C's that are here. Right, in this system over here. Right, the number of C's over here contributes to our answer, right? Because, for example, if there was a C here, that means that this would also be a solution, right? Ending at this C. If there was a C here, that would mean that this would also be a solution ending at this C here. So the point I'm saying is for any character C, we could say, okay, this is the ending at C area. So what can I attach myself to? I can only attach myself to things that start with C over here. And if that doesn't make sense, we'll just do that in this example, right? So when I look at this first A, I say, all right, I have an A here. So how many strings, this is the ending A. So how many strings can I form to the left that start with A? Well, it's the first character, so there's just this A. So all I get is A. I look at this B, and there's nothing I can do. Then I look at this A, and I say, okay, I found another one now. So I've added another solution with just A. But also, how many strings to my left can I use that would add to this A? Well, I'd say, okay, well, there's one A to my left, so I can attach myself to that, right? And create A, B, A. Then I look at D, and there's nothing I can do. I look at A again. I say, okay, I could have this A alone. And then I ask myself, how many A's do I have to my left that I can attach myself to? Because all I'm trying to do is saying, if I'm the ending A, I need a starting A. So how many A's do I have to my left that I can use as starting A's? Okay, I have one A to my left, ADA, right? And I have two A's to my left. I'll put it down here, ABA, DA. So all I really did is I walked through this system, right? One by one, and I saw a character and I said, okay, how many things do I have to my left that I can connect you to? All right, and then when I got to this character, I said, okay, I could have this character by itself, but also I could connect it to this C over here, and I could connect it to this C over here. And that's the general idea, right? So all that needs to really be done is when I count through this system, we'll do it again with the character C. So we'll have characters just X's. And now this time the X's actually represent X's. Just as an example here. I look at this and I'd say there's nothing I can do. Nothing I can do. I'll keep counts of the C's that I've seen and I'll keep count of my solution res. So, okay, there's 0 C's, 0 C's, 1 C. How many solutions can I create? Well, I can create just the C by itself, and there's no C's to the left that I can use, so that would just give me one solution. All right, the same amount of C's here, the same res, same amount of C's, no new C's. I see another C, and I say, okay, I can create an additional one with the C by itself, and how many C's do I have to my left? So these will give me +1. Well, I have one C to my left that I could connect to, so that would give me another +1. So that gives me another 2 solutions. So now I have 3 solutions. I go here and I say, okay, I have a C, so I can use the C by itself, right? So now there's 3 C's. And how many solutions do I get? I get myself +1. I can attach myself, right? I can attach myself to this C to get another +1. And I can attach myself to this C to get another +1, right? So now I get +3 to the solution, so that gives me 6. Ya. Lo siento. Max, mi perro está gritando. ¿Quieres ver? A floating perro in the sky. Okay. Hasta para allá. Hasta para allá. Hasta para allá. Para allá. Para allá. Para allá. Okay. So this would be, where am I? So 3, 6. Same amount of C's, same amount of C's. And then when I go here, now there's 4 C's. I get 1 for this C by itself. I get 1 attaching it to this C. I get 1 attaching it to this C and another 1 attaching it to this C. right? And that corresponds, I don't need to actually go back through the system, right? Because I would just say, okay, for this C, there's 3 C's I can connect it to and add that in here, right? So that'd be 6 plus 3 plus yourself is 1. Okay. Now, we can think of it this way, but one really quick kind of not really an optimization, but something to simplify your code as well. There's 1 here, and we add 1, right? There's 2 here, and we end up adding 2. There's 3 here, we end up adding 3. There's 4 here, we end up adding 4 to our solution. So one way to simplify this is saying, well, you know, the number of solutions I can make, the number of substrings I can make, meaning the condition, right, is the number of C's that I've seen, right? So when I look at this ABAA thing, right, I'm going to delete this and clean it up again, doing this res idea. So we'll have the number of C's that we've seen in res. We'll call it CC. So how many A's have I seen? 1. So that means I can add 1 to my total number of solutions. How many A's have I seen? Just 1. So still 1. How many A's have I seen now? I've seen 2. So I can do A and then A. You know, I could do this A and then any A to what's left. So I have 2 A's. So I add 2 to my solution. Same thing. Now I have 3 A's. So I add 3 to my solution and 6. And then this is just your answer. Okay. So the code here then is only the following. All we got to do is make a little code block here. This is how easy it is. We'll have res and CC equaling 0 and 0. We'll look at all characters, I don't know, X and S. I'll say if you know, if the if X is a C, that's not right, terrible. If X equals C, then the counts of C's, we get plus equal 1. And we, whatever. If X equals C still, so ugly. Res plus equal CC. Right, because that'd be the number of new solutions that you get, I guess. Max, cállate. My dog is losing his mind today. A veces estás demasiado cómodo conmigo, ¿ah? No puedes gritar cuando estoy grabando un video, ¿entiendes? Okay. Sorry, my dog only speaks Spanish, so I had to learn Spanish so that we could communicate. See? Okay. So that's really just the idea. So just to summarize this crazy mess here as well, if it has to start with a letter and end with the letter, then we'll look at each letter and consider it. Okay, this is the letter we're looking for. This could be the ending letter. So then how many of the same letter have I seen before that I can attach myself to? And that just results in the number of times that we've seen that letter. All right. So, So let's write this code then. All right. So we're going to just seriously write it exactly as we wrote it there. Look at all X and S, and we'll say if X equals C, CC plus equal 1, and I wrote it a little bit weird the other way, res plus equals CC, right? So if I'm seeing the letter, that means there's another place where this could be the ending point, and I can attach it to all the times that I've seen this letter already. Ta-da! All right, now what is the run and space complexity of this? Okay, so let's say n is the length of S. For time, all right, we create these 2 variables. It's constant time. We look at all n letters. We do a constant check. We update a variable constantly, right? So for all n letters in S, we do constant things. So we do n constant things. So that's big O of n. For space, independent of the size of the input, we only create these 2 variables. So the input is 1,000,000 characters, 5 characters, 400,000 characters. We only create these 2 variables and we update them accordingly. Okay, so that's big O of constant 1 space. All right. Hope everybody has a beautiful rest of your day. Bye-bye.